Assalamualaikum warahmatullahi wabarakatuh. My name is Irfan. My number matric is 21 DDT 22F1181. So we from the class DDT2G. So I want to talk about problem-based task introduction to network. So here is our member of this group. The first one is Nofai Akbar bin Muhammad Akbar. His number matric is 21 DAT 22F1179. My second member is Daniel Asri bin Basri. His number matric is 21 DAT 22F1178. My third member is Muhammad Afif bin Kamalulil. His number matric is 21 DT 22F1193. And the last one is me, Irfan bin Shahidan. My number matric is 21 DDT 22F1181. So, here is our table of content. The first one is the hardest part of to complete the BBT. We'll pass to Daniel Asri. We'll talk about that. The second is task distribution. Afif will talk about this, and the third one is a PPT summary, and I will talk about that, and the last one is a verify connective. Fahim will explain that. So I will pass to Daniel Asri to explain the hardest part to complete the PPT.
Bismillahirrahmanirrahim. Assalamualaikum and hi everyone. My name is Daniel Asri. So first of all, thank you so much to my brother, Irfan, because of his introduction for the first part. Okay, so I would like to present the hardest part to complete the PPT. Okay, guys. So throughout the project, we faced various challenges, but there were a few areas that require extra effort and attention to detail. Okay, without wasting our time, let's go for the first one. All right, the first one, task 3. Construct IPv4 addressing and perform subnetting was particularly challenging. It involved calculating the IP address required for each subnet and designing the addressing scheme table based on the given specifications. So, subnetting can be a complex concept, especially for those who are not familiar with it. We had to understand and apply subnetting calculations as well as bitwise operations to determine the network addresses and subnet masks accurately. So, showing the calculation of process for each subnet was crucial to showcase our understanding and ensure the correctness of our addressing scheme. It required meticulous calculations and careful documentation of the step-by-step process. So, for the task 3, it's a bit hard for us to do because we need to do further research to understanding the various concept of calculating the subnetting IP address for each subnet for the given specifications. Okay, so that was the first one. So let's go for the second one. All right. So for the second one is task 4, routers, host, and server configuration. So this part also presented its own set of difficulties. Configuring the host name and IP interfaces for multiple routers and hosts was time consuming and demanded accuracy to avoid any misconfigurations. So the configuration of the server's hostname and IP interface also require additional steps such as setting up specific services or applications on the server. So this does involve a deeper understanding of server administration and network services. For this one, if we miss some part of configuration, we might as well get missed with the connection between routers, host, and server. So for this particular task, uh, all of us need to concentrate while doing the configuration so that we might not get misconfigurations. Okay, and also the last one, finally, the task 5. Configure wireless router and clients pose challenges in terms of configuring the wireless router to meet the specified requirements. So we need to set up the SSID, the password, DHCP settings, and IP addressing demanded a solid understanding of wireless networking concept. So for example, okay, for the laptop, so we need to change the component PT laptop uh, on that component. So we need to remove the empty slot and change it to WPN 300N. So with this, we can access the DHCP. We can enable the DHCP protocol. So we need to so the ensuring that all Cafe WR clients receive IP address dynamically from the wireless router required troubleshooting skills, as any misconfiguration could disrupt the DHCP functionality and prevent proper network connectivity. So if we are able to do the DCP protocol, so and then later then the connection to the wireless router can be successful. All right. So overall, while this task presented challenges, we were able to overcome them through our collaboration, our further research, and deeper research for all of those subnetting and networking, and also all the configurations we made, and utilizing available resources. So I would like to thanks especially to my Madam Zamharia, because without her guide, we weren't able to complete all the network topology. So our so for the next slide will be task distribution. Will be presented by Mama Afif Zikri. All right, thank you.
Hello everyone, my name is Afif and I would like to present about task distribution. First, that's me. I took charge of task 1, which is initial settings configuration, and task 2, network design. I ensured that all routers and switches were configured with the required initial settings, such as disabling DNS lookup and enabling the appropriate password. I also designed the complete network topology based on the number of hosts per subnet specified in table 1. Next, we have Fahim and Irfan. They collaborated on task 3, which is to construct IPv4 addressing and perform subnetting, and task 4, routers, hosts, and server configuration. They also calculated the IP addresses required for each subnet and designed the addressing scheme table as outlined in table 3. They also configured the host name and IP interfaces for all routers and hosts based on the assigned IP addresses in table 3. Lastly, we have Asri. Asri took charge of task 5 to configure wireless router and clients, also took care of task 6, which is verification. He configured the Cafe WR network device, setting the SSID, password, and enabling DHCP for the Cafe area subnet. Additionally, he ensured that all Cafe WR clients receive IP addresses dynamically from the wireless router. As part of the verification process, he confirmed network connectivity among hosts and captured the output for part 6, verify connectivity. Next, we have PPT summary, which will be presented by my friend Irfan. That's all for me. Bye.
Thank you, Afif. So I will talk about PPT summary. So here is our PPT summary. The first is the problem. How to configure network device and performing subnetting and set up a wireless network. So the benefit gained from this task. First is an enhanced understanding of network configuration and subnetting concept. Second, practical application of theoretical knowledge in a subnetted network environment. The third, cooperation and teamwork skill development. Number 4, problem solving my mistake. Problem solving and troubleshooting ability improvement. Number 5, increasing familiarity with network device and their configuration. So, I will pass to Irfan Akbar bin Muhammad Akbar to verify connective.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurfayim Akbar bin Muhammad Akbar, and with number matrix 21 DDT2F 1179, I'll be presenting to you the output for our PBT, and I'll show you how to verify connectivity between devices. Okay, let's get going. Here, the first one is we are going to verify connectivity between JTMK PC1 to GRK VPC3. Okay, to access this command prompt where we're gonna write our command, you just need to click on the device on your Cisco Network Packet Tracer, go to Desktop tab, and then out of all the choices, you're gonna have one that's called Command Prompt. Okay, right there, you you click on command prompt, and you're gonna use the ping command. Ping command will be used to basically locate where these devices are on the network. All right, so we're gonna ping 192.88.77.36. This is the IP address of JRK VPC3, and this is how you're gonna use ping. You're gonna ping the ping, and then you're gonna use the IP address of the one that you're going to locate, the one you're gonna verify your connectivity with. All right, so here ping 192.88.77.36, and you're gonna say pinging with 32 bytes of data. And as you can see, there are 4 lines here, meaning there are 4 packets sent. Alright, and one of it is request timeout, meaning that 1 packet is lost. Alright, so here ping statistics for 192.88.77.36 is packet sent is 4, receive is only 3, and loss is 1. That means we have 25% loss on this verified connectivity pinging. Alright, now here approximate round trip times in milliseconds is minimum is 0, maximum is 11 milliseconds, and our average is 3 milliseconds. To the next one, we're gonna be verifying the connectivity between Student Cafe PC2 to Cafe WR00. Okay, this is the port we connected it to. All right. Cisco Packet Tracer PC command. All right, we're gonna ping 192.88.77.14, which is the IP address for Cafe WR. And as you can see here, 4 lines are sent and all is successful. Okay, so the ping statistic for it is packet sent is 4, receive is 4, no loss at all. Approximate round trip times in milliseconds is 70 milliseconds, maximum is 53, meaning that the average would be 32. Next. Alright, here we are going to verify connectivity between JRKV PC1 to DB SRV. Alright, so the same process, open desktop, open command prompt, click on ping, okay, use command ping, and write down the ping address of DB SRV. See here, pinging 192.88.77.72 with 32 bytes of data. Alright, here it says request timeout, the same with the first. Same with the first just now, and here there are 3 lines that are successfully sent. Okay, ping statistics for 192.88.77.72, packet sent is 4, receive 3, loss is 1, and another 25% loss. Right, the approximate round trip times in milliseconds is 1 millisecond, maximum is 27, and average is 9. Okay, that is all of our output for this PPT. And thank you for watching. I'll be passing this to Nukman Irfan to close up this presentation. Thank you very much.
So thank you, Fahim, and thank you for your all attention. I hope you understand what we talking about. So we hope see you again. Bye bye.